Good morning, FMT students. Welcome to Foundation Phase Mathematics. Today I'll be doing a revision of the exam and what is expected of you as you answer the questions that are going to be posed to you in the exam. First of all, the key factor is looking at the outcomes, because when I do my exam, I look at the outcomes, and you should be able to do the following things to prove that you are competent in Foundation Phase Mathematics teaching. In the outcome number 1, I'm expecting you to be able to apply and evaluate the key terms and concepts that deal with terminologies and theories of teaching relating to Foundation Phase Mathematics. I'm also expecting that you are able to apply a range of strategies and methods that help you to teach mathematical concepts related to numbers, operations, geometry, measurement, data, time, patterns. Out of all that, I also expect that you are able to demonstrate how you integrate your pedagogical knowledge with the Foundation Phase Mathematics, meaning that your teaching of it. Do you know how to do an introduction? Do you know how to grasp your learners? Do you know how to teach the concept as a body and how you wrap up the lesson? I'm also looking at the different teaching strategies that you're going to employ in order to teach a certain aspects and why you chose a specific way of teaching it. Remember, when we start with new knowledge, we use the teacher-centered approach. And then once the knowledge is understood, then we can use the learner-centered approach. Another thing that we're going to be looking at is identifying and analyzing and critically reflecting on mathematical problems that are familiar and unfamiliar, and how to do that using case studies and context. Identify and explain different assessment methods, meaning that there isn't one way to assess learners. Remember, when we assess learners, we do observations, we use rubrics, we do formal written assessments, informal assessments, verbal assessments in the class, and using cues. So now the first aspect that we touch on in mathematics and foundation phase is building a number sense in children. When we develop a number sense, that incorporates counting. It also incorporates children understanding what is less than, what is more than, what is big, and what is small. When we say that, it has to start from a CPA approach. That means concrete, pictorial, abstract approach. You first start with concrete things that you show them, where they physically try out the experiments, as in 50 takes longer actions to count. Then 500 or 250 takes a lot more. 5 counters can be held in one hand, 50 maybe in 2 hands, and 250 require maybe a container of some sort. So being mathematically proficient means that you are well versed with mathematics. You are numerate, and that means you have a good understanding or conceptual understanding of what mathematics is. You have a good understanding of what numbers are, how to use the numbers. You're also able to apply what you've learned using the strategy or the method that the teacher has taught, and now you can take that method and make it your own. That is now the adaptive reasoning. Production disposition, meaning that you're able to engage with it in order to solve a problem. Whichever direction that the problem is posed at you, you're able to solve it. At the end of the day, this makes you to be procedural fluent. You are fluent with the procedure that we've taught. You no longer need to follow the steps in order to solve the mathematical problem. When the teacher asks the question, if I say 5 times 20, you already know the answer without having to go through the steps, because you automatically know it in your mind. When we come to patterns, space, and measurement, patterns, it has to be through copying that you're going to show them how to be able to identify the segments of the pattern, copy the pattern, extend the pattern, complete the pattern, and also be able to find the missing part of the pattern. So there are many ways to do this. You can use matchsticks, tiles, blocks, and other apparatus to teach the children this aspect. When it comes to space and shape, Space and shape is taught through handling concrete shapes and completing tasks such as building objects, covering, tiling surfaces, making a new shape and objects, that children develop a sense of the relationships and properties of the shapes and objects that they are working with. They develop a sense of what is equal on both sides, equal angles, equal areas, unequal, bigger, smaller, and less than. Remember again when we're dealing with measurement and data handling, through measuring, firstly informally so, by using their hands, they measure the length of one student to another. Then they can use a string, they can stand next to the learner and be able to assess. They can even line up building blocks and lie on the floor and measure one another. Then it becomes a formal aspect where we use muchness is a sense of how big something is. Through measuring, they also meet up with situations which cause them to think about the need for parts of a whole, to describe certain quantities. An important introduction to this concept of this is fractions. So we look at data and how we handle data, the collecting of the data, the sorting of the data, and making sense of it using graphs and pictures. Then I'm going to go in through a basic lesson on how to teach mathematics. What are the key components of a math lesson? First of all, I spoke about the introduction, the body, and the conclusion. So in the introduction, we begin with a hook. A hook must be something that learners are going to be hooked on. It's something that is going to be enticing. It's something that's very interesting and makes them want to learn more. So when you begin a lesson, you need to make it fun, interesting, in such a way that learners can't wait to hear what's next. That we call the introduction. And then when you start with your introduction, link it to prior knowledge of learners, what they already know, and bring it into your lesson. Then you make your intentions clear as to what it is the lesson is about. This becomes now the body. The body is where the major content is going to be taught. The major content such as collaboration, problem solving, mathematical investigations. So once you've taught the concept and you've taught the steps, now this is the part where the body part where you introduce other learners to work as peers, as groups, doing collaborative work, giving them problem solving exercises to do to make sure that they have understood the concept that you've taught there at the beginning. And then you wrap it up by either doing a formative assessment, summative assessment, or some sort of getting an idea of the thing that you have taught. How well have your learners understood what you have taught? I did again speak about the different teaching approaches. We spoke about the teacher-centered approach and the learner or the child-centered approach. This you need to know well on how to use it. What is your role as a teacher? How you construct the knowledge? What is the learner's role when you're using the teacher-centered approach? What kind of assessments you can use if you're doing a teacher-centered approach? What are the things that you need to emphasize? Or what would you be trying to emphasize if you're using this type of approach? Again, on the far right-hand side, the learner-centered approach, if you're trying to construct knowledge that learners are teaching themselves something that you as a teacher have already taught, it cannot be something new. It's something that you're reinforcing knowledge onto the learners. The learners are themselves guiding one another, and the learners are active participants in this. And the assessment is either continuous oral observations, maybe a written exercise, and this gives a deeper learning sense to the learners. In the teaching of your lesson, remember there are the learning theories that we dealt with. There's Piaget, there's Bruner, and there's Vygotsky. Again, when it comes to those three, learning theories deal with the cognitive development of learners. Cognitive development, how learners acquire knowledge. And then we have Van Hiele. Van Hiele focuses solely on measurement and objects, shapes, and how we learn that. Those are grasped at a different sense of learning. So he identified 5 levels, and these are visualization, analysis, abstraction, deduction, and rigor. They happen at different stages of a child's development. Two things that that should be noted here are that they are independent, meaning that any person at any age who is developing geometric understanding will move through the levels. It's not expected that children will move much beyond the abstraction level at this point in the foundation phase. They are well into their teenage years. So, in other words, there is little expectation that children will, in the foundation phase, reach the deduction, the rigor, and visualization. So, if I see that in the paper that you're writing, that you're using this stage, it clearly means that you do not understand how the Van Heel levels work. If you look at a square, because it looks like a square, those are some of the reasonings that children will say at a foundation phase level. You give them a square shape and you say, why is this a square? They can't really express why it is a square because they haven't learned the properties of the shapes yet. So they will say that it looks like, because that is what you as a teacher have presented to them as a square, as a triangle, as a circle. So foundation phase children who are given a pile of shapes can easily sort them in different ways. However, when they asked to describe the criteria that they use to sort the shapes, they can do little more than say the shapes in each pile belong to each other or together. So we look at the analysis of children. When it comes to analysis, at this stage, children analyze and can recognize and name the properties of the figures. That this has edges, this is round, this has an area. So they're able to see the relationships between them. Again, we look at, because we said it's age independent. If I look at the abstraction part, children at the abstraction stage of their development, this is usually around about grade 3. They're able to start to perceive the relationships between the properties of the figures which they are working with. They start being able to make meaningful definitions and give informal arguments to justify their thinking. So it's not expected that many foundation phase children will reach this level of understanding, but you as a teacher get them to the level and just make it part of your introduction. Then we have the deduction and the rigor. Deduction and rigor, although we do not expect children in the foundation phase to reach these levels, they are described here for completeness so that you understand the whole aspect of Van Heel's level. At the deduction level of thinking, children can construct proofs with an understanding of the roles of axioms, definitions, and they understand the meaning of the necessary and sufficient conditions. At the rigor level, children begin to understand the formal aspects of deduction and can solve problems, geometry problems, and can develop both indirect proofs and proofs by contradiction. In addition to identifying and describing the levels of geometric thinking, Van Heel developed a description of the different components of a geometry learning experience, which supports children's development. We start with free play, focus play, vocabulary that you use, further focus play, and your consolidation. Then I spoke about the 3 cognitive development theorists. The big father being Jean Piaget, who maintained that children learn in a continuous process by constructing knowledge. He believed that children acquire information by interacting with objects, ideas, and other people. He also believed that children construct knowledge through 2 processes of, namely, adaptation and assimilation and accommodation. When we speak about assimilation, this is when children add new information to the existing thought structures. In other words, the new information or experience fits in with what they already know. Accommodation takes place when children make changes to the existing thought structures so that new information from the environment can fit in better. When we look at this, it means that children develop through maturity. He proposed a series of stages through which intellectual maturity moves. He claimed that these stages are fixed and follow each other, but accepted that no fixed time for each stage. Piaget suggested that children proceed through stages of development, and these stages are the same for all children according to their ages. So he spoke about the sensory motor stage, the pre-operational stage, the concrete operational stage, and lastly, the formal operational stage. I won't go through much of this. It is in your study guides, and I've gone through it in many of the lessons. Hope by now you understand it well. Then we come to the social constructivist theory, which is Vygotsky. He took on what Piaget proposed as a theory of development and added to it. And according to him, children make sense of the world through shared experiences, and learning occurs in the zone of proximal development. The ZPD, zone of proximal development, encompasses the differences between what a child knows and what a child can learn, with the assistance of a more knowledgeable person such as a parent, a peer, a teacher. In this social interaction, children learn significantly more and learn deeper concepts than she or he would on his own. So we use the approach of scaffolding, which is a process which a teacher adds support for learners in order for them to learn and master certain tasks. The teacher builds on the learner's experiences and knowledge as they are learning new skills. And the implications of Vygotsky's theory is that we will now turn to the implications of this theory for teaching and learning in relation to the role of learners, the role of teachers, and the learning environment, meaning that when you're teaching children, you teach the concept. Then you get to the point where now they should be able to do it on their own. You can use either scaffolding in the form of suggestive questions, scaffolding in the form of creating a safe environment for children to learn and ask questions and better understand, ask the whys. How come it doesn't do this? Why is it that we only use this number? What happens to a fraction when the number at the bottom is 0 and such things? That's where you come in and you give that padded information. So now when we're looking at the role of learners, because learning is actively constructed and learners come to learning situations with already formulated knowledge and ideas and understandings. Learners' previous knowledge forms the basis for the new knowledge that they create. Learning, which is designed as mediation in the ZPD, can lead to cognitive development. Therefore, teachers must expect more of learners than they are currently able to do. A learner creates new understanding for him or herself. A teacher provides structured mediation to guide a learner in this area, which is the ZPD. Learning is collaborative. Learners learn about learning, not only from themselves, but also from their peers. As a teacher, you are the guide or the support structure. The teacher is instrumental in developing a child through the process of mediation. Mediation refers to the active guidance that the teacher gives as an intervention and problem-solving task. A teacher must provide that structure as guidance to learners to enable them to accomplish with assistance something they cannot accomplish on their own. The teacher can do this by means of giving an example, asking questions, either wrong or right, and seeing whether learners understand. And this is the scaffolding or the sparking of stimulation and intentionality. Tasks should be set outside children's actual developmental level to determine their potential to learn. And teachers must identify what concepts and skills learners already know and plan appropriate activities to extend their knowledge. Then we come to our last developmental theorist, which is Bruner, Jerome Bruner. He believed that children learn by actively engaging with the environment. And according to Bruner, learning is an active process in which learners construct new knowledge or concepts based on their current or past knowledge. A learner selects and transforms information, constructs concepts, and make decisions, relying on a cognitive structure or schema to do things. The following principles that underpin Bruner theories have implications for the teaching and learning of mathematics. He spoke about different stages, which is the inactive knowledge. Inactive knowledge comes from physical manipulation of objects and children's own movement. This involves all that the young children is doing, for example, sorting, counting of objects. And when they do this, this is to such as shapes and say that this is the shape and I'm putting it into this box. So children use their fingers to count and things like this. It's something that they're actively doing. Iconic knowledge is the one where there's a mental operation happening. Children use where children use representations of concrete objects, for example, using pictures thereof. This emphasis here is on visual and perceptual information. An example of this kind of knowledge is when children are provided with a picture of 3 butterflies and asked to draw a flower for each. Symbolic knowledge refers to the ability to use abstract knowledge or symbols. The goal in mathematics to reach the highest level of symbolic knowledge. That is now when they no longer use manipulatives to count and you can just give them a sum like 1 + 1 and they're able to give you the answer of 2. You must be able to compare the different theories in terms of their social context, how they construct knowledge, the different developmental stages, the key processes that they each spoke about, and how they use knowledge as a form of a comparison. Remember when we spoke about Bruner, he spoke about different learning styles. And in mathematical classrooms, it means that you will include some explanations, some discussions of the concept by exploring and meaning through manipulatives such as blocks. Remember to make them gender specific. Sometimes you cater for the boys, sometimes you cater for the girls. Gender differences in these modern times is unthinkable that there's still often a perception that mathematics is more for boys than for girls. The opposite has also been argued in research that some adolescent boys struggle more than their girls counterparts. So in recent times, this emphasis or this myth needs to be squashed. We need to make it bring some equality in the emphasis of the way we teach it. We also need to recognize our talented and gifted learners. These learners may often be perceived as non-attentive, naughty, or even dumb. However, they may be exceptional in areas such as reasoning, memory, and problem solving in different ways. It's also necessary to provide the support for creative thinking and divergent approaches to problem solving, taking into consideration those with physical impairments such as hearing, vision, and other senses. At the end of the day, mathematics relies on visualization, and this may become a problem for visually impaired learners. So learning difficulties in recent years focuses on the focus has turned away from fixing problems, but rather concentrating on how to adapt the curriculum to be more accommodating to all learners, as well as methods and strategies that are going to make learners to make meaningful mathematical concepts and apply them and show how they can prosper and flourish. In inclusive education, meaning that in our teaching, we need to use different styles. I cannot emphasize how important this is. Every person has their preferred way of learning through hearing, touching, moving, or seeing. It's therefore important to develop lessons that could address all these different learning styles. In mathematical classroom, it may mean that you have to include some explanations, discussions, manipulatives, so that learners get the full grasp of what you are teaching. Because if you don't reach all your learners, that is where we lose children in mathematics. Remember again to be cognizant of the gender. In these modern times, it's unthinkable that there's still often a perception that mathematics is more for boys. So you need to create activities that not just the speed of the car, how far it was going, the distance between this. You need to include things that females can also relate to. Again, we spoke about the talented and learners with impairments or disabilities and how to solve them. So when we have learners with difficulties, it means that we need to make the lesson more accommodative. This implies that the teacher must be vigilant in identifying the difficulties and adapt and plan your lesson to the learners that you have. Thank you.